All right. Make sure we got everything up. Level's good. Welcome to the stream, friend and friends. I'm Agent Ultra. And on this stream, we like programming. We learn about programming. We do things with programming. A lot of functional programming mostly, but, you know, branching out a little bit here and there for fun times. But for this one, we're going to be learning how to... I'm trying to learn how to and figure out how to make a multi-user dungeon. A mud server in Haskell. A mud server? What is that? Well, it's a multi-user dungeon. It's kind of the precursor to massively multiplayer online RPGs from back in the day. It is primarily text-based, right, but it's still real-time with multiple people connected at the same time playing the game with you. The game still updates when you're not doing anything. It just keeps going, just like an MMO. And yeah, so that's what we're doing. Yeah, we're doing that because I'm learning how to embed Lua in Haskell applications, and I'm learning a little bit more about the STM library. We're seeing how that works on larger scale applications, and things like that. So that's what we're working on, and we're doing that in the lovely Haskell. I seem to have lost the music here. Hopefully the stream is still connected. You'll have to let me know, chat. Things are looking a little dicey. Here, maybe it's just pretzel. We'll just try that. Okay. Maybe a different track. Sure. There we go. So that's it. Yeah, multiple people connected at the same time, playing the game at the same time. Text-based. So you're given text commands to do things, and you get a text result of what you see. And yeah, that's what you got to do. So this week, last week, and the past couple of weeks, we've been working on implementing some new commands for the Lua API to move players around. I was thinking this week I might want to just bite the bullet and restructure a little bit the, not too much, but the low-level server where we spawn all of our threads and all that stuff. I want to make sure that when one thread is killed due to like maybe an IO exception or something in the server, that we just crash the whole server. The idea being that, you know, these things usually happen because of programming errors. So if you wrote some bad Lua code as the game designer, I should just crash. I'd like to be able to catch the Lua exception and get the backtrace from it so we can show you that, but no sense continuing the server when the code is bad. And, you know, other things, like if the simulation has a bug in it, it should crash, right? And we should, as much as possible, aim to make the server as fault tolerant as possible, but there ain't no recovering from those sorts of things. So right now we're using this fork thing here to fork off these threads. And the default in Haskell's runtime when it's forking off thread is just to fork it off as a child green thread. But if it crashes, it doesn't crash the main thread. It doesn't throw the exception back to the main thread. It just disappears. There is a way to fix that though. So I'm going to look into that, and we're going to learn about how to do that this week. That's what we're going to do. I think it's in the async package. If I'm not mistaken. All right, syncs async high-level API spawns lexically scoped threads, ensuring the following properties to make it safer to use than plain fork IO. So no exception gets swallowed. Waiting for results propagates exceptions, and no thread is leaked, left running unintentionally. This is done using the bracket pattern to work in the presence of synchronous and asynchronous exceptions. Most practical production codes only use the high-level API. Maybe, but probably. So the basic type is async A, which represents an async IO action that will return a value type A or die with an exception. An async is a wrapper around a low-level fork IO thread. The fundamental function to spawn threads with the high-level API is with async. For example, to fetch two web pages at the same time, we could do this. Assuming assumable get URL function. All right. Some use cases require parallelism that's not exactly lexically scoped. There is a low-level function async which can be used in the direct as a direct equivalent to fork IO. But it still has a problem. Okay, why are we showing a problem? Probably is illustrative, I guess. It still fulfills property 1, and that the exception arising from get URL will be rethrown by wait. But it does not fulfill property 2. Property 2 being, if an exception bubbles up through, then the async spawn, its spawned is canceled. No thread is leaked. Okay. Second async may be left running in the background, possibly indefinitely. With async is like async, except that async is automatically killed if the enclosing IO operation returns before it is completed. Furthermore, with async allows a tree of threads to be built such that children are automatically killed if their parents die for any reason. If you need to use the low-level API, ensure that you guarantee property 2 by other means, such as linking asyncs that need to die together and protecting asynchronous exceptions using bracket mask or other functions. Maybe I want to refactor to this. I wonder, so link is the thing. I wonder if there is something in that in the just the low-level languages that we're using. We don't want to wait for child threads to complete, necessarily. Maybe it is only an async. Link. No. Bound thread. Okay, operating system threads. Mirror. Okay. Maybe not. So I think maybe we'll probably go and try to maybe refactor this all to async if we can. Doesn't look like we have the instances on asyncs for that. And with async runs an IO probably. It's an IO action. Okay. Maybe we can work it on in. So how do we... So raise is good 2 IO actions concurrently. Turn both results. 4 concurrently. Map concurrently. Replicate concurrently. The E. We have a version of await that can be used inside an STM transaction. Ooh. Okay. I don't think we need to use that, but it's neat that it's there. Okay. Waiting for multiple. Yes. Yeah, there we go. Link the giving async to the current thread such that if the async raises an exception, that exception will be rethrown in the current thread. Wrapped in exception in linked thread. Link ignores async canceled exceptions thrown in the other thread. So that's safe so it's safe to cancel a thread you're linked to. If you want a different behavior, use link only. So these are what we need. We just spawn our asyncs and then call link on them. Right? Or does link just fire them off? Okay, so yeah, it looks like it fires them off. So we just call link instead on our asyncs. In there. Okay, so figure this out. It's going to be an interesting refactor, integration, doohickey change. Go. Just make sure chat's there. Okay, chat, what's up? All right. Do. Let's get our async package. It's just async 226-ish. I'll add it to Cabal. Up here. Yeah, we'll just fix it. And hopefully that builds just fine. Yeah. Okay, we're good to go there. Okay, now to integrate it with us here. Now we have these fork Bakamud functions because they're basically running inside our Bakamud server monad and doing brackety, weird IO low-level thingies. That code, fork Bakamud, comes from reader, yeah. Because we have to call the run Bakamud server function in order to run other Bakamuds in our child threads. Yeah. So maybe we can put them. What do we need to do? We need to lift IO, link this back. Do we have to do link in? It's an IO action. Okay, so we don't have to do it in a with async. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't have to do it in a with async. We just have to do link in. It's an IO action. Okay, so we don't But we have to define our threads as async A's to run them. Constant control, concurrent async. How do we wrap those in an async? Is there a way to turn my thing into an async so that we can run it? Because if I just replace this with link, right? Function argument problems. Because it's accepting just an async, but if I try to make it like one argument like that, say, that's not going to work. Oh, yeah, we don't need the handler argument. In this world, I don't think. So we're going to get rid of that. Don't have a handler anymore. Okay, and then apparently GHC says that should be a unit. Now, yeah, run Bakamud server here is not an async anymore. We expected a Bakamud server async. Hey, we got a Bakamud server IOA. So how do I create an async? By async or with async? Okay, so we gotta spawn it to get the async as an IO action, and then we can pass that to link, I guess, to link it to the main thread. So, yeah. We'll lift IO that part here. And then that. So now GHC is saying that we couldn't match types here for some reason. It's got an async of something, so the A0 is, when we want an actual type A, because that's what we return on Bakamud server A here. So it's like, I don't know I can't resolve that. That's what it's saying. I can't figure out what the return value of that is. And that's what the type of server is. So think if we make these together the same, that might do it. Unit. Don't know if we can actually fix that to unit, because I think we use this for other things. It's got to be a. Maybe we could do this in one lift IO. Maybe we could do that way. Async. Okay, so the reason why it's getting upset here is because we want to get the value of the A here, but originally I think we had just thread ID, so if I do fix that to unit, the problem here is async, we still can't figure the types to get them to line up. Async is, it's an IOA, should be returning the same A. Okay, we gotta run it separately, yeah. Okay, let's progress. So run Bakamud server here is got an arrow in it still, because it needs another argument. Yeah, that comes from Monad, right? Oh, sorry, it's the anyhow. Right, so once a server state and a Bakamud server action. Server state. And Bakamud server action. Yeah. That should be fully applied. Oh, I'm looking at the wrong file. That's what it is. Hey, Twitch TD, how's it going? Yeah, I got a haircut probably like a week ago or so. Last week. How you doing, bud? Friendo. It's looking in network servers. Bump over there. Yeah, yes. Get rid of that, get rid of that, get rid of that. Interesting. So we had I just removed this function here, which was like a finalizer, because we pass off this resource to this child thread, which if the child thread failed, it would call us and close this. So this actually might be better, because that resource should be owned by the main thread. Let's see if this the server runs, compiles. Let's check it out. Here, no, Alright, we're gonna have to telnet in. Alright, still runs. Welcome to Bakamud. So now I want to test the error path here and cause some exceptions. Because we know when we cause one, right, the server just hangs, it becomes unresponsive because like a critical thread has crashed. Cool, so we're connected, we're looking around, we're trying to go haul, it did that. So let's go mess up our Lua code. Cause some kind of problem. Like that. Start that off. Oh. Might have worked. Already. Bakamud. There we go. Sweet. That's what we wanted. That was easy. A lot easier than I thought it was going to be. I thought that was going to be a huge pain in the butt. But no, once again. Good libraries. Good language. All good. Okay, so let's create a little committee commit for that. The main change is in reader, I guess. So we added the async dependency, we changed fork Bakamud. Uses async to link threads to main. There. Cool, cool, cool. All right, so let's, now that I got that out of the way, that was nice and quick. Let's get over to the command, I guess, and get back to where we were. That stuff. Or, another little cleanup task I wanted to look at was getting those back traces from Lua. Let's see if we can do that. Let's look maybe in, probably not in lib, but traceback. All right, Lua L traceback creates and pushes a traceback of the stack L1. If message is not null, it is appended at the beginning of the traceback. The level parameter tells it which level to start the traceback. So it takes two state parameters, L and L1. Interesting. We append a C message to it. How would we use that? Okay, let's try and figure that out. Let's go to server, our high level server. There's our Lua interpreter lock. That's kind of not what I'm looking for. All right, so for example here, we call into the user's main module there for the various, for command handling. We call that handle command function. So in this scope, we have L state. And when we get the result, Lua code failed, I guess we can look in here. But what two states do I need? I guess maybe the initial state, we should probably take a reference to that, run that block, and then get the state again. And that would tell, maybe like that's the Lua interpreter's way of figuring out what the change between them, like what they did. Initial state, maybe. And we want to get server state, Lua interpreter state. We're kind of digging into internals here. Good times. And then in this block here, next state, ask for the same thing. Then maybe we can run this Lua traceback thing. Although maybe there's a higher level API. I think that's a low level one. HS Lua core. Oh, that's better. Okay. That was the low level API I was looking at. This is a nice higher level one. So we just need to give the one state and then maybe a string, a level. Not okay. Let's see what that does. So let's get rid of this. Yeah, let's get the interpreter lock again. This might be a little bit weird. This might be a little bit weird. Yeah. Because if I get the interpreter lock here, there's nothing guaranteeing that something between this action that posts the result, like, you know, puts the value of result in this variable here, and this next action in this when block, there's no guarantee that something else doesn't get the interpreter lock and runs in between, in which case our traceback might get a little bit messed up. So, how do we get that? So maybe we got to take that out. We're going to inspect the result of R here. I'll just call it result. Put the traceback here. Maybe that will work, because I don't think we use result any other way. So we don't need it anymore. Yeah, then we pure unit. I think that should go. Let's see what GHCI says. We got to return a Lua status. So then we have to the result. Oh, right. Result is a maybe here. How do I... Oh, wait. Sorry. That should be it. Okay. Sorry, the reader has a little fix in it we need to make. This is no longer needed. There we go. Just stage that quickly. I should have gotten the last commit. Whoopsie. Just rebase that, squash that in. Back to server. Okay. So let's put the trace back in. Else state. Int. Okay, cool. So that compiles. Let's see what it does. Let's introduce that Lua code again with the error. I'll restart the server until I figure it, until I add the code reloading feature. And this should trigger it. It doesn't. Okay, for some reason it doesn't. What am I doing here? Well, maybe it would be like if I did a percentage, but I put like a number in. Maybe that'll do it. Okay, that's not an exceptional situation. Well, maybe I can introduce an error like, maybe it's that way. Maybe it is that way. It's not usually this hard to add an error to a Lua script, to be honest. Usually a lot easier. Oh. Something happened there. We're not dying though. Oh, gotta be authenticated first. Okay, maybe that could have been why. So, no, that should have been fine. We should have been authenticated before we got to that point. Twitch TD, you know, I don't know if it has a debugger that would, that we could trigger. I'm just trying to get it to print out the traceback, which I know we do have. Or at least it looks like we have something that can do it. But I'm just trying to figure that out. It'd be interesting if it could. I don't know if we could, I wonder how that would work though if we did have something like that. I was like, this is from a host program, right? Maybe. Could be pretty interesting if it did. So let's try Bakamud. Bakamugger. Let's try logging in. Choose one. Look. And go Hall. Everything's fine. Fine. Okay. Was it? Oh, it's literally translating it to a string, and that's totally great. For once I can't actually get the Lua code to crash when I want it to. What else can we make that? Maybe like just something ridiculous. There we go. No, we just got the Haskell exception there, but it didn't seem to do anything. Okay, the exception was thrown by calling into Haskell. Okay, it wasn't a Lua exception that I triggered there. So what if I do just the connection? Well, that's going to call into Haskell again, cause a Haskell thing. I thought the string format thing would work. Like, put an S in there, but then I give it a number or maybe a table. That should parse. But not be right, or do something weird. Hilarious. Hilarious. I was getting all kinds of Lua crashes all the time from making dumb Lua code, and gotten too good. I can't get it to, can't do it anymore. What's happened? Simple Lua to cause an exception. Throw, I could throw. Error, something went wrong. Assertions, okay. Thanks, Google AI thingy. Lua doesn't seem to have a general debugger error, but it does have XP call, which calls a function with an associated error handler. Cool, thanks Twitch TD. Let's take a look at that too. XP call, okay. Yeah, on the Lua side, you can catch things. Yeah. So what I'm trying to do is get that stack trace, but I want it from the Haskell side. So like when we call the user's function, sometimes the game programmer might have like made a mistake in their code. And the Haskell server, right, can check the results of running the code. But it just returns an either when it does this. And all we can do is say like, okay, or no, this Lua result is what we get from the Lua interpreter. So like if it didn't work, we just know it didn't work. And so we just, I throw the left in that case. And then we get like errors that look like, anyways, we get like a Haskell error, like could not, whatever I wrote, could not run a Haskell function. And it's that point that I want to display the traceback that we're trying to get going here. So we're calling lua.traceback. But yeah, I think this would be maybe the easy way to trigger something funky so that the result is not okay. So that my code catching it can display that traceback. That makes sense? Yeah, but like in straight Lua, if you're trying to catch an exception on the Lua side, yeah, you got to use this XP call thing. It doesn't have it built in. It's kind of weird. Kind of a funky little language. All right, so we log in, we choose, and the look command has the error in it. But we're not getting... the result is still fine. Well, look isn't doing anything though. But the result is still okay. Or if it is throwing a traceback, it's not printing anything. If that works. I don't know. It might not be working the way I think it is. I think it's supposed to print out the traceback from the Lua interpreter. Make that a debug.trace then. Yeah, that's what I'm trying to that's what I'm trying to suss out. Like, do I have to print anything? Like, it's just an IO unit function. Or like Lua E unit. So it creates and pushes a traceback to of the stack L1. Of the stack. It's wrapping this lower level Lua L traceback function. If a message is given, it is appended to the beginning of whatever. So like maybe I gotta pop, it pushes it onto the stack and I gotta pop it off in order to print it. Maybe. Interesting. Okay, okay. So pcall is what I think what the code's using to call the function. Pcall trace. Okay, this is sounds like it's supposed to sets an appropriate message handler function, thereby adding a stack traceback if an error occurs. Okay, that's what we're using. So maybe like it's just not working. There's the call to pcall. Remove status. Get the top of the stack. Function index. Remove from the stack. So just set some message handler. Thereby adding a stack traceback if an error occurs. But we haven't seen any of that, so I don't know what the heck this is talking about. Like I just throw an exception in the Lua code. Error, haha. How about you need to call toString after the traceback? At the stack index. Okay, maybe. Maybe. Let's try that. Thanks for the tip, Twitch TD. Let's give that a shot. Then we toString. Prime. Stack index. There's probably a named stack index for it. Bottom, nth, top. Just top. Let's see if Haskell likes that. Stop the server, please. Cut it all out. I don't. Yeah, we're almost there. Yeah, 2-string. I was just wondering if I have the byte string imported. BS, 2-string. Oh, .utf8. Oh, what is it? Oh, for the package UTF-8 string. Dirt. Ah, HS Lua Core has it already too. Oh, but they don't export it. Why? .utf8. There. Okay, let's try that. Run it. All right, we've got our exception here on line 32 in our Lua file, so hopefully when you hit that line, it throws an exception and we get a traceback in our server log. That would be super cool. No. Sort of. Something. Something. The server is still good though, right? I mean, our function isn't, but okay, so it's printing at the this traceback thing. Okay. Then what if I put That's putting a traceback on. If I do that. Okay. Interesting. Oh, thanks, ad blocker. You've made my day. Okay, so it's kind of doing something. What if pcall trace is already... I don't know what the heck it's doing, pcall trace, to be honest. Like, it's doing something, but it's not catching exceptions and like printing out a traceback. You know? I think this is weird. It might creates and pushes a traceback of the stack L1. I don't know what of the stack L1 is kind of getting at here. So if we go to the lower level one, it takes two arguments that are both state, so two values of state. So is that like, how would that even work? It's a foreign call, the Lua function itself. All right. Lua L traceback. Okay, so when it calls pcall here in Lua, we get a status and an error. We don't get that in the Haskell side of things. No, let's close that up. With pcall trace, we just get the status. There could be like, maybe they stuff it in there in the Lua E error. Core, okay, let's look at pcall. And I just want to look at the source of this one. Just call Lua P card, P call underneath. Converts it to a status. Okay, calls a function. Message H is nothing, then the error object returned on the stack is exactly the original error object. Okay. So otherwise, when message H is just index, the stack index is the location of a message handler. This can't be a pseudo index. In case of a runtime errors, this function will be called with the error object, and its return value will be the object returned on the stack by pcall. Typically, the message handler is used to add more debug information to the error object, such as a stack traceback. Such information cannot be gathered after the return of pcall, since by then the stack is unwound. Message H is the maybe stack index. Okay. So what this is doing then is that in the error case it's going to, that is nothing, the error object return is exactly the original error object. So if there was an error, it'll be on the top of the stack. Otherwise, we can set the index in the stack of the location where we want to put a message handler, which I'm guessing is what the wrapper does in the high-level HS Lua core pcall trace. Maybe. Let's check that out. Pcall trace. No results. Source pushes a C function, message handler there. Insert just below. And then we do pcall and args unres, and we give it, yeah, just base. We give it the that stack index. We calculate the offset of that from the, yeah, so we put that at the bottom underneath the function. Okay, that's what it means. We'll remove base and then return status. Okay, so that handler, some kind of C code. I think it's probably that. Yeah. It's a C function. Interesting. Why would they... That's... Okay, okay, this is the actual function here. So this is a helper function used as a message handler if the function given to pcall fails. So it tries to get an exception. Okay. traceback L just message. 2. So yeah, this should, I guess we're kind of doing the same thing. I guess traceback is supposed to look at that. I wonder if 1 is just not enough arguments, like stack-wise. Maybe it needs 2. Maybe this will do it. Login as Bakamud with foobar. We trip up with our look command. No, sort of. Foobar. Okay, there's our message. Stack traceback. Maybe we got to give it 1 more. Maybe it's on the 3rd line. That's interesting though. So it's printing foobar and stack traceback, colon, but nothing else. Message gets with the toString like we're doing, coercing it to exception, stack index 1. Let's try it like this. Oh, yeah. Where's the exception come from? HS Lua core error. Lua.exception. So pcall trace should be doing that. I don't know. Try that, see how that goes. Hmm. No. Printing table like that. It's not quite what, If I do it just like this, I think that was just my debug trace, wasn't it? Let's get rid of that. And fire that up. Oh. No, so there was something about the message. Lua to string. Top. Bring back trace in there. Yeah, should work fine like that, I think. Okay, but log in, choose. Moment of truth, no. Okay. Yeah, so it is pushing onto the stack this value, but it's got nothing in it, I'm guessing is kind of the thing. So we gotta build our own traceback object. That's what it's for, I guess. Switch CD wants to know what the top +1 index contains. It would be split over multiple indexes. Could. Now some kind of user data object. I wonder if the HS Lua documentation has an example. That's not a whole lot of documentation on anything about exception handling and printing tracebacks. Dang, dang. Type classes, packaging. HS lure, traceback, display, teaser. Ah, cool, Twitch TD. Yeah, so we're using pcall trace. Error run pcall trace. 2-string top. So top level, would there be a traceback at all? Yeah, like we get a status from that result. What if I just get this? I don't do push this traceback thing. So it's not that. I get the message off the top. Show that. Maybe that's what it is. Because it sounds like traceback pushes an object on, so maybe it's used for something else. Yeah. Okay. That's looking a little better. That's looking like a traceback. We're just showing this in the debug log. Okay, interesting. So traceback, red herring. It's just on the top of the stack. If the result is not Lua okay, I guess. Interesting. So we could error with that string, maybe. And that would be probably fine. Oh, wrong tab. Do, 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 do. Okay. Good, good, good. Let's try that out. Nice, nice. Ooh. Okay. So we get this now. So I think we can actually revert this code and just do the simpler thing. Yeah. Kill that. Go back. Message. I'll do it at top. Yeah, we just do that with Lua. To string message. That, okay. Yeah, Pandoc uses it quite extensively. It's pretty cool. Oh, right. Because we're not in the... So I did need that change. Okay. Okay. Oh, well. Maybe. I think that'll hopefully be working. There we go. Okay, because I just want to see though. I just want to see the trace back there. I think we're almost there. I think we almost got this. Okay, exception. There we go. Well, it's still kind of shows it a little funky. Like we get this line here. I guess if you're a game developer, like using Lua, maybe that makes sense to you. So So it's on the right line. Prints out the error string. Haha. So I don't know how much influence I have about how the Lua tracebacks get printed and what they look like, but I'm assuming this is probably good enough. It's not great, but hopefully it'll be like pretty useful if you're used to programming in Lua, I guess. Yeah, okay. Let's commit that. And maybe we can do the same pattern in other places where we call the Lua code. Yeah, okay. Ta-da. So we modify Bakamud server.js. Added, or no, changed. Handle token list. Displays traceback. Lua traceback. On error. Okay, let's do a similar thing for, I think there's a couple other places where we call the user code, like handle login. Right? So let's get rid of something like this, just ignore, bump that in to there, I guess. Pop this up here. I'm just going to call that results. And maybe we want to put a little message there, like this is handle login. Just gonna need the import probably. Oh, okay, we do need the results still there. Unit? No. We just have to return pure unit. We just have to run that for the side effect, I guess. It's still return pure unit. A pure unit. A pure unit. There we go. Okay, cool. That's right. Pcall trace. It's the only two we have. Okay. And add accept traceback to handler, to login handler. Yep. That's that for that one. I think that's all the places. Well, there's one in the low level here where we're just loading the Haskell code. We're adding our API functions. Do we check the error? We just say it could not load Lua code. Okay. We could also do that here, I suppose. As long as we use pcall. Yeah. UTF-8 there. There we go. Okay, and that also that should display a traceback on startup too when we're loading the code if there's an exception found in loading the while loading the code, like things like that. So cool. I think that's all the places we do pcall there, so that should be all of them. We'll make that a small change. Modify Bakamud network server.hs. Changed. Run TCP server. Should displays Lua traceback if there's a problem loading code. Exception loading code. Okay, cool. Those are some little quality of life improvements and fixes there for the server, so that's good. Let's push those up. All the code you've seen tonight for this project, it's called Bakamud. It's up on GitHub. I'm Agent Ultra. And yeah, I'm Agent Ultra on GitHub as well. Now let me paste the link there. Bakamud. All right, so give it a like, star, whatever it is. Follow along if you're interested. And there you go. Thanks again for watching and tuning in. You can find me on the Fediverse. I'm on the types.pl server on Mastodon as Agent Ultra. AgentUltra.com is my website. You can find links to my GitHub, YouTube channel where I back up the VODs for this stream and a whole bunch of other things there. So check that out and give us a follow here so you can catch updates on the stream and other projects that I'm working on and just general nonsense. And go to the link above my head. That's declarative.tv, little website there where you can find other streamers doing things in declarative programming languages like Haskell, but also Elixir, Erlang, and a whole bunch of others. There's also a link to a Discord server on that site. So there's a channel for this stream there and all the others where you can hang out and talk with like-minded folks and join the community. So check that out as well if you're interested. Thanks for hanging out with me. May all your motives be free and your types always check. And happy hacking out there.